Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look and see what we got here. Lesson 6.2.3. We are now going to go through the process of making sure that everybody knows how to show their work, how to record it. This is especially important as you get into more complicated math, that you get in the habit of copying the problems down and showing your work. I know many bright students over the years have been able to get away with solving problems in their head without writing much down, but this is going to become overwhelming. It's going to get really challenging to try and keep track of everything in your head. And if you don't start practicing recording your work the right way, then before long you're going to become overwhelmed. And I wouldn't say I have taught a large percentage of students that fit into this category, but I've certainly taught quite a number of students who all the way through 5th and 6th grade were able to get A's on everything in math because they could do everything in their head. And by the time they got to 8th grade, they were getting C's, D's, and F's, not because of a lack of math ability, but because of a lack of recording their work and losing track and not being able to solve problems after a while, and then just starting to struggle because it's hard to catch up. So I'm going to say this, I'm going to keep saying it. It's really important that you record your work the proper way. So let's get into it. In this lesson, you will continue to improve your skills of simplifying and solving more complex equations. You will develop ways to record your solving strategies so that another student can understand your steps without seeing your equation map. Well, we haven't really been doing that with equation maps anyway, but you are going to develop ways to record your solving strategies in such a way that someone else should be able to come over and look at your work and tell exactly what you have done and why you've done it. Okay, so consider these questions as you work. How can I record the steps I use to solve, and how can I record what is on an equation mat after each step? Okay, but we are going to graduate away from the equation mats very soon. All right, Jane and Aiden were using algebra tiles to solve an equation. Aiden was called away. Jane finished by completing the table below and on lesson 6.2.3 resource page. Okay, so let's hold on for a second. I don't remember looking at the resource page. Hold on. Okay, so yeah, apparently there is a resource page that is on your online book for lesson 6.2.3 that pretty much looks like this. I would have to bet by the time you sign in, access this, and printed it off, you could probably just copy this down in your journal. So that's what I've done with students in the past. I didn't bother printing that page off, but feel free to go do that if you want to. You can pause the video, get this printed off, and then come back and be ready to fill in these blanks. So what is happening here? You've got this original expression for mat A, and you got this original expression for mat B, and these two together are making, it's saying that this is equal to that. That's supposed to be an equal sign, by the way. Let me do a better equal sign. There we go. Okay, so that's the original equation. So what we need to do is go through the steps to get this completely simplified, and then eventually begin the process of solving for x by using the legal moves. And so what we're going to do is we're going to look at this. It says use distributive property, right? So before we can get started, let me actually change the color here. With the simplifying process, like I want to combine these x's inside here with these x's here, but I can't because they're kept inside of parentheses. So you've got to start with distributive property. So go ahead, use distributive property, and then rewrite the expression here. Here, that one doesn't have to be changed at all. We could just keep that exactly how it is because there's no distributive property here. So every time you do a legal move, you rewrite each expression until eventually you get to a solution. So what does this look like after you send in the dive bombers? Well, the 2x isn't affected by distributive property, and the -3x nor the -6 are. It's only the quantity inside the parentheses. That becomes 4x plus 2. So 2x plus 4x plus 2 after doing distributive property plus the negative 3x plus the negative 6. All right, now let's switch it up a little bit. Now something happens here to simplify this expression to look like this. Something happens here to simplify this expression to look like this. What is that called for what happened here? There's a very specific term. In some cases, you are just combining like terms, right? In other cases, you're removing zeros, but it all falls under the category of combining like terms. Okay, so the 2x and the 4x make 6x's, and then the 6x's plus the negative 3x's makes 3x's because you would have removed zeros, 3 negative x's with 3 of the 6 positive x's. So I am a big fan of having students highlight the terms that can be combined. Remember, all of the x terms, all the variable terms get combined by adding the coefficients together. 2 plus 4 is 6, and 6 plus negative 3 is positive 3, so it becomes 3x's. And here you've got 2 and negative 6. Once again, turns out you're removing zeros because you have to add a 2, positive 2, to 6 negatives, and as a result, you get 4 negatives left over after removing 2 of those negatives for 2 of those positives. Here, same idea. You got your 4x's that combine with the 1x to make 5x's. Then you got this 3 and this negative 3 that cancel each other out because they're a zero pair. Remove them, and what you have left are these 8. Okay, so if you have to do distributive property, that's the first thing you do. If you don't have distributive property, then your number one focus is to start by combining like terms. Then we start removing balanced sets. So this says subtract 3x from each side. So if you take away this 3x, you get the negative 4. When you take away 3x's from the right, remember you had 5x's over there. You take away 3x's, that leaves you with 2x's plus that 8 that's still there. Now, what is happening here? I see something is happening in both places, but our goal is to get our 2x's by themselves. So how do we make that number right there go away? Well, same idea. We removed balanced sets in this row, taking away 3x's from each side. Now we're going to take away 8 from each side, which you could almost call it adding 8 negatives if you wanted to. You could say subtract 8 from both sides or add a negative 8 to both sides, and that would serve the same purpose. This would cancel out, leaving you with just 2x's, but here you'd have negative 4 and negative 8 combining to make negative 12. And then once you have 2x and negative 12, well, I know 2x's is negative 12. So what number do you multiply times 2 to give you negative 12? That's going to be the answer here. Negative 12 divided by 2, and you get negative 6. So in all of these situations, all of these remain equal throughout the process because we are using legal moves. Whatever you do to one side, do the exact same thing to the other. Here we removed 3x's from each side. Here we removed 8 from each side, and here we divided each side by 2. So we're always doing the same thing to both sides of the equation. That is how you solve an equation. So I would like for you to copy this down. The steps for solving equations. Remember, I put here, if necessary, you don't always have distributive property in your problem. So if you don't, you move on to the next. You may not have to combine like terms, right? If you had just started right here, let me go ahead and do something here. If you had started with this as your equation, you wouldn't even have to combine like terms. All you'd have to do is start removing balanced sets. Add or remove balanced sets until you get all of your variable on one side and all of the constant on the other side, the number, and then the last thing you should do is divide. This is what happens most of the time. Sometimes you may actually end up multiplying as your last step. As you get into 8th grade and high school math, you might find a square root as your last step. But for right now, this, for the most part, is going to be the process. So if you need more time to copy it down, go ahead and do that. I'm going to move on. You can always pause. Okay. Aiden was frustrated that he needed to write so much when solving an equation. He decided to come up with a shortcut for recording his work to solve a new equation. As you look at Aiden's recording below of how he solved 2x plus 4 is equal to negative 12, visualize on a map with algebra tiles. And I can't stress this enough. If you are actually thinking about or reflecting on what we did with those tiles or what I showed you with those tiles on the algebra map, it's going to make it so much easier to understand what's happening here and why we do what we do. Okay, I do not want you to memorize the process here, although I did have you write it down. I want you to understand why we're doing what we are doing. Okay, so I will often say something like this. 2x plus 4 equals negative 12. What was the 2x's equal to before we added the 4 on, right? This 2x's must have been negative 16 because negative 16 plus 4 is negative 12. So how do we show that? By removing the 4 that was added in here. So when you remove the 4 here, you also have to do it to the other side because we're trying to find out what this number was before we had added the 4. That's the number after 4 was added to 2x. So let's undo that. Use the inverse operation of taking that 4 back away. And negative 12 minus 4 is the same as negative 12 plus a negative 4. So that's how you know that 2x's must have been equal to negative 16. So what was this legal move when he wrote negative 4 each time? That's what we refer to as removing balanced sets. What legal move does circling the 4 and the negative 4 represent? Well, there's a reason why we circle it that way, because it makes it kind of look like a 0, right? That's the idea of creating a 0 so that you can remove that 0 and just say, okay, these go away, leaving you just with the 2x's. Now, think about this logically again. 2x's is equal to negative 16. That means whatever x is, when you double it, you get negative 16 for an answer. So what must x have been before you multiplied it times the 2? Well, let's go ahead and take negative 16 and divide it by that 2, right? Think about your math facts. If we say 2 times x equals negative 16, then we know that x times 2 equals negative 16. We know that negative 16 divided by x is going to give you 2 for an answer, and negative 16 divided by 2 will tell you what x is going to be. So when we reflect back on our fact families, this is the one that's going to tell us the solution for x. So we'll divide each side by 2 because whatever you did to this side, you got to do to that side. And notice what that forms right there? That's what this question is all about. What does the box around the 2 over 2 represent? That is what we have always done for a giant 1. And that's our goal. To solve this equation, we have to get 1x all by itself on one side of the equation and a number all by itself on the other. 1x, we're not going to write the 1 in there. It's just understood that that is 1x. But that's what is happening there. When you divide each side by 2, you create a giant 1. 2 divided by 2 is 1x. So why did Aiden divide both sides by 2? Well, because we want to just have 1x left over here, and whatever you did to the left side, you had to do to the right side. You could have also said that dividing by 2 is the inverse of multiplying times 2. Remember how here you had the opposite of adding 4 is to subtract 4? Well, the opposite of multiplying times 2 is to divide by 2. Those are inverse operations. To kind of undo what you had done. So 2 times x is negative 16. So if you undo that, you would divide by 2 to get back to where you started, which is negative 8. So he's still kind of showing the steps. I don't know why they were saying up here he was frustrated that he needed to write so much. I mean, we're not really having to write too much there. There's only 2 steps to get to the answer there. So I don't know. He still wrote a bit, which was very useful. All right, so check Aiden's solution. How do we know we got everything correct? Well, this was the original equation. We think -8 is the solution, so we're going to plug that number in. 2 times -8 is -16, and -16 plus 4 is equal to -12. That is correct. We can draw a box around our answer and declare that the answer is indeed -8. All right, method of recording the steps in the solution of an equation is useful only if you understand what operations are being used and how they relate to the legal moves on your equation map. Find the work shown at the right on your resource page for this lesson. Do I have a resource page for this lesson? Is this, I don't know what this is. Hold on for a second. There's a resource page. Is there a different one? Why is this on the resource page? It's not. Or is it? Oh, there it is. We don't need it. Just copy it down. Resource page. Just copy this down right there. Okay. So for each step in the solution, add the missing work below it. All right. So first off, pause and copy down this line right there, and 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 that right there, and leave a little space in between so we can fill in some gaps. Okay? I'll give you a chance to fill that in while I go take care of something. All right, so our first step, remember, distributive property? Nope, no distributive property here. Combine like terms? Absolutely. Let's add our 6x and our 7x, or I'm sorry, our x and our 6x together to give us the 7x's. The -4 gets to stay where it is. And no x's over here besides the 3x, so let's combine the -1 and the 5 to make our 4. So that very first step is combining like terms. Now, what has to happen here? We want the x's. Ooh, they did it in a slightly different order. I like to start with the x's, but it looks like they took care of the constants first. So they're deciding to get the 7x's by themselves. So what do you do to make that -4 or -4 go away? You add the opposite to it. What's the opposite of -4? Would be +4. So if you add 4 to the left side, you have to also add 4 to the right side. So this would be showing the step, okay? Notice where the equal sign is. Adding or removing balanced sets requires you to make sure that you've done something to the left side and you've done the exact same thing to the other side of the equation. So some students do this. Some actually write the equal sign in there so they see, okay, we got to make sure that we're doing something on each side. Because I've actually had students that have actually added 4 twice on the left side and didn't do it to the right side, forgetting where the equal sign was. All right, so now we want to get rid of these 3 x's, right? We don't want them on the right side of the equation. We want to only have x's over here. So how do you make those 3 x's go away? Well, take them away. Subtract 3 x's from each side. So now, after canceling out those -4 with the +4, that made a 0 pair. Now this makes a 0 pair. So you just have the 8 is equal to 4x, or 4x is equal to 8. So the last step, 4 times something equals 8. To figure out what that is, let's take 8 and divide it by 4, and that will tell you what that something is. So 4x divided by 4 gives you 1x, and 8 divided by 4 gives you 2. So I'm not going to draw a box around this. I'm not ready to declare that as my answer until I check. So let's start with the original equation. Copy it down. If you wanted to reduce your writing and you wanted to immediately go to this step, I would be okay with this, right? There's your x, and there's your x. It's not a bad idea to just copy down the original equation, make sure you got everything right. All right, now we're going to use the order of operations. Stop it. You got to do the multiplication here first and the multiplication there first in each one of those expressions. That becomes 2 plus -4 plus 12. This becomes 6 minus 1 plus 5. Now we just add from left to right, or in any order that you want. 2 plus -4 is -2. And -2 plus 12 is 10. Here you get 6 minus 1 is 5, and 5 plus 5 is also equal to 10. So we saw that when x was equal to 2 in this equation, that each one of these expressions simplified down to positive 10. So that means I can go ahead and draw a box around my answer. I can declare that x is equal to 2 with a high degree of confidence. All right, so now I am going to ask you to justify your steps along the way using the basic terminology, and you can even use abbreviations. Let's come back to here for a second. If you remember, these are the basic steps that you use. So, distributive property, call it distributive property. You can say DP. Combining like terms, removing zeros, you can say CLT/RZ, or I would be okay if you just did CLT. That can be your justification. Adding or removing balanced sets, adding the BS or removing the BS can be used. And then divide, just write divide, that's fine. Or by the time you get there, I'm okay if you just finish it. Well, no, still, justify it. Since the directions say to justify. All right, so please pause and copy down this equation. This is the original, okay? So sometimes you'll notice that it said that here. So start with the original equation, boom, and then begin the process. You don't necessarily have to write down original equation, but it's not a bad idea. So the justification is going to be on the right, and the work that you show and the new equations after doing those legal moves will be on the left, and then we'll check. Okay, take some time to solve this, and then write down what the steps were, remembering the order that you already wrote down in your journal. Follow that order as you solve. All right, let's see how you did. The first thing you want to do is distributive property. There is no distributive property, so we move on to combining like terms or removing zeros. In this case, you might have a little both. So there's the negative 2x and the positive 2x that are going to cancel each other out. And you've got a 5 and a negative 5 that are going to cancel each other out. You're going to end up with nothing on the left-hand side. That's 0. On the right-hand side, what do we have? We've got the 1, a negative 1, and a 2. All those combined, negative 2 and 2 is going to make 0. The only thing you're going to have remaining on the right-hand side is your negative 6. So what do you multiply times 6 to give you 0 for an answer? Well, it's going to be 0, right? And how would you show that? Well, I suppose you could show dividing each side by 6. 0 divided by 6 is going to give you 0. So yeah, that would be the last move, would be to divide by 6 technically, but we think 0 is the answer. So I'm going to declare that, but not until I have properly checked. So I'm going to plug in. There was an x, there was an x, and there was an x. And each one of those is equal to 0. So you end up with 0 plus 5 plus 0 plus negative 5. On the left-hand side, the 5 and the negative 5 are going to cancel each other out and make 0. And on the right side, the negative 2 and positive 2 are also going to cancel each other out. Since 0 is equal to 0, this proves our solution is indeed 0. Now, if this bugs you and you want to rewrite that as x equals 0, I totally get it. Go ahead and turn those guys around. It won't make any difference at all. All right, do the same thing with problem B. This one I see does have distributive properties, so you'll want to take care of that first. Okay, go ahead and pause as you work that out. All right, let's see how you did. We start with our original equation, and then we do distributive property, right? Send in the dive bombers. So that becomes 3 times 4 is 12, and 3 times x is 3x. So we rewrite that as 12 plus 3x is equal to x plus 6. Now, combining like terms would be the next step, but you've only got 2 terms on the left side, and it can't be combined because this is a constant, that's a variable term. Same on the right. So our next step is to begin removal or adding balanced sets. So let's start by taking away an x from each side. So if you take away one x from this side and one of those x's from this side, you end up with the 6 all by itself, and then 2 x's plus the 12. Then, since our x's are on this side, I would recommend taking away the 12 from each side, or adding a negative 12 if you want to think about it that way. Both of these steps involve the removal of the balanced sets. So 12 minus 12 is 0, so you just have your two x's, and 6 minus 12 is negative 6. Last step to our solution, 2 times something equals negative 6, so negative 6 divided by 2 will tell you what that is. If you divide both sides by 2, you get x is equal to negative 3. So let's test that out. We think x is equal to negative 3 here and negative 3 here, right? There's one x, there's the other. So let's go ahead and go through the order of operations. This becomes 3 times 1, which is 3, and negative 3 plus 6 is 3. So yes, 3 is equal to 3. We feel good about our answer. Let's go ahead and draw a box around our solution to declare that as our solution. All right, now let's approach a problem so that we can integrate solving equations with the 5D process for word problems. Oliver's building a train depot for his model railroad. As his final step, he needs to apply rain gutters around the roof of the rectangular building. I think this one is perfect for drawing a picture. He has 52 centimeters of rain gutters. So that rain gutter goes around the rectangular building, so that's going to be like a perimeter here. Length of the depot is 19 centimeters. Explore how Oliver can find the width of the depot by answering the questions below. Okay, so find the width of the depot using arithmetic. Actually, what they want you to do is they want you to do the 5D process where we do a guess and check process. I would actually prefer that we solve it algebraically. Do we have another one that we have to solve? No, that's going to be the end of it. So let's see what I did here. Maybe we did it both ways, or maybe we just do it one way. So what information do we have? We know it's a rectangular building, and we know that the length is 19 centimeters. What we don't know is what the width is. But we know it is a rectangle, and we're finding the perimeter, so we can use a perimeter formula to figure this out. Now, it does say that the total perimeter is going to be 52. So when we define our variables, we know that our total perimeter is 56 centimeters. We know the length is 19 centimeters. We just don't know what the width is. So we need to create an equation for this. And the equation is going to look like that, right? These two sides added together plus these two sides make up the perimeter, which is 56. So go ahead, combine like terms. It gives you 2 W's plus 38 equals 56. And now from here, I'm going to pause it, let you pause it, and go ahead and do the 2 steps necessary to get your solution. All right, so the first step, we want to get the 2 W's by themselves. So if 2 W's plus 38 is equal to 56, what were the 2 W's before we added the 38? So let's take the 38 away from the 56, and that gives you 14, right? Now let me just go ahead and show this real briefly. We are removing balanced sets here, taking away 38 from each side of the equation. They cancel each other out because that's a 0, leaving you with just 2 W's. But here, 56 minus 38 is 14. Now, what do you multiply times 2 to give you 14 for an answer? Go ahead and take 14 and divide it by 2. That's going to form a giant 1 here because you want this to be 1 W, not 2 W's. And 14 divided by 2 is equal to 7. So we believe that the width of this roof, the rain gutters here, you need 7 centimeters worth of rain gutter there, and the 7 centimeters worth of rain gutters here. How do we know that's going to be the case? Well, let's go ahead and check that. We think our solution is where W is equal to 7. So let's plug those in, and let's add all of these numbers together. 7 and 7 make 14. 19 and 19 make 38. 14 plus 38 is equal to 56. No, it's not. That is not equal to 56. No. No, 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 no. No. I'll be right back. All right. There was a mistake that was made here, but you know what? Look at everything here. Everything is so clearly recorded. I know exactly where my mistake is. Just took me a second to come up here. And the magic number is supposed to be 52, not 56. So let me change that right now. Change this to 56. 56. No, it's not 56. It's 52. Change that to 52, which means I got to change that to 52. Boom, 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 52, which means this has to be 52. And for some reason, 52 minus 38 is equal to 14. I did the math wrong, but I got extremely lucky. This was not supposed to be equal. I mean, if that had been 56, this would have been 18. I don't know what I was thinking, but I did that mentally, and I made a mistake, but I lucked into it because the solution is equal to 7, because 52 minus 38 is equal to 7. So now when I check it, I'm going to check it based on this supposedly being equal to, what was I doing there? I just wrote in all sorts of wrong information. Boom, boom, that is correct. All right, let me use the calculator just to make sure. 52 minus 14 is 38. No. Well, okay, that'll work. It's supposed to be 50. I'm so tired. I need to stop doing this. 52 minus 38 is supposed to be 14, and 14 divided by 2 is 7. And 7 plus 7 plus 19 plus 19. Yes, it's supposed to be 52. It is equal to 52. So I'm going to declare the answer. Write an algebraic. Did I not declare the answer anywhere? Okay. Oh, it's right there. So the answer is the width is 7 centimeters. All right. Happy times. This concludes day 1. We still have day 2. So I'm going to end it right there, and tomorrow we'll pick up with the rest of it. Take care. Bye.
Hey, feeling good, like I should. When in dark,